Hi everybody. Today I am going to show you how to calculate the provided reinforcement area for this slab, and also we learn how to modify the reinforcement area due to exceeding the deflection. Actually, in previous video for this slab I explained how to calculate required reinforcement area, and it was theoretical. So let's start this one with set calculation options for provided reinforcement. Here for this object inspector, this is a panels, this one. Let's find this panel number. It is panel 1. Select this. So it is selected. Slab is highlighted. Now design, then provided reinforcement of RC element. Click here. So this layout, it is divided into two parts. Just wait for some time. So we close this and click on this zoom all. It is very clear now. Okay. Zoom all, by zoom all we can better visualize the slab. That's what we want to do this. Next, click analysis and go for reinforcement pattern. Here this bar, this general, click on bars. Done here. Go for construction reinforcement, just deselect this. Click OK. So to display the provided reinforcement maps, on this slab and shell reinforcement dialog, we click on reinforcement maps, then select provided reinforcement AR, not required one. So click here. Now to improve the visibility of the reinforcement maps, or this one, on this display, say here we remove these descriptions, also deselect this panel numbers. Now to adjust the grids of reinforcement maps to the slab, we go to this grid parameters, grid steps. Say put here 8, here also 8, and grid type, click on regular. Then here we can see the generation. Click on generation. So once it is done, go for analysis again, but look at this calculation, click here and calculate. So what we are finding here, bottom provided reinforcement area for X direction displays in the view. If we want to view the reinforcement for other directions, look at this corner, left corners. I mean this left corner, you can go, suppose this is now X minus, you can go for Y minus, X plus, Y plus, automatically it will be changed. Say look at, if I click Y minus, it comes as this. Zoom all, it will be in nice shape. So this way we can check for all these options. And another important things, largest amount of the provided reinforcement is located in the middle of the slab. If we look at the value, you will find it. And therefore the results are appropriate regarding the opening and the method of supports, what we have done. Now we will verify the deflections for the provided reinforcement area. So how to do that? So in this regard, we'll go again for the analysis, go for verifications. Here click on displacement, this negative, and attached with that this must be here, combination 2. Because in previous video I explained how we got the load combinations. So once it is done, we can click on calculate. Now here we can close this. It is written here has been exceeded, deflection value for the panel number 1. This is panel number 1. So close this. Also close this verification dialog. Now come on here, this one, slab and shell reinforcement dialog. Here finite element results. If we click on this, it is deflection maps. What is happening? Look at deflections. As well, in the display group, we can deselect this mesh. Now, deflection, it is smaller than the required reinforcement, but it is still extended to the value. We can see it here. It is minus 26.1. Now, we will try to modify the provided reinforcement. How to do that? We will go for this one, slab and shell reinforcement dialog, and the rectangular reinforcement map, this one, it is popping up as rectangular reinforcement map. If we click here and make sure that provided reinforcement AR is selected, now click on bending, and instead of automatic we will choose this manual. What is happening? Once you choose the manual definition of reinforcing zone, right where the bar table of reinforcement, we can see it here, bar table of reinforcement bar is enabled, and we will use this table to modify the reinforcement parameters. So here we can see a dot. Let's click on this dot. It will be highlighted with black colors. Now we want the point coordinates here. Suppose from here, say -2, 4, this point, another point 2, 4, this point. So this zone will be considered. Say here in coordinates, I am writing -2, -4. Then again 2, 4. So we selected 2 points. -2, -4 means somewhere here, this point. And 2, 4 means somewhere here. So this rectangular part is selected here. P1 and P2 are the 2 points I have taken. This point P1, this is P2. Now it is highlighted green. Now add it. See, it is X minus, it appears as 29 here, like this one zone name. If I click here, say I can select this. Again, if I click here, I can select the number of steel. You see here. Again, I can change the spacing also. Even I can increase the zone of reinforcement. Reinforcement here also it is showing. So this is the way to do this. I mean, modify the reinforcement parameters. We can do it selecting other zones. Now our next things we'll do, we'll verify the deflections for new reinforcement area. How to do that? We'll click again analysis and go for verifications. So once we are here, verifications, we'll select this and these two should be here. Then calculate. Close this dialog box. Now what you can do here, say we can go here for the reinforcement tab, and this is to be with the X minus, and here you click this one, deflection map again. So this is actually to use the provided reinforcement after verifications. So we can compare seeing these values. We can compare seeing these values. I did not do any big changes, just I am showing the procedures. Even for required reinforcement option also to compare the deflections before and after the verifications we can do, and here we are doing for provided reinforcements after verifications. Now once it is done, I mean verification is done, then we can go for display the final reinforcement and the drawing. That's the procedure I am explaining. So what to do here? In this case, here say slab provided reinforcement. What we'll do, we'll go here and click here, go for RC design, and here slab reinforcement, click here. So once we got this, now we have to go for again analysis and calculations. Now click on calculate. Okay, but make sure here we got these things. Here bring this, we got like this, and click here, select this. See, it is appearing material properties, concrete, longitudinal steel, transversal steel, everything is here. And now here we saw RC component in inspector, this one, and reinforcement view, it is top and bottom. Look at this, plus and minus, and this is actually reinforcement bar dialog, and this is reinforcement table. So what to do now? Suppose if I click on any reinforcement, say here I am putting something, say whatever, say I am putting a 1, say this one, right away it appears here, this is the bar. Here it is positive. If I click here, it will be negative, and we can also find the steel also by clicking. Now we can see the drawing for this. Say click and results. So what is that? You go for the results and you go for say drawings. So you got it. But if you go view and go for the say next drawings, see, you get the drawings. We can edit or modify drawing elements and their contents. How? If we go view, then we can click on these drawing components. Then we can edit and modify the drawing elements here. So totally what we discussed in these topics, first we set the calculation options and ran the calculations of the provided reinforcement area. Second, I showed how to verify the deflections for the provided reinforced area. Then I showed how to modify the provided reinforcement area manually, because I put tick on the manual. Then I verified the deflections of newly created reinforcement area. And now I display the final reinforcement and the drawing what we can see here. So I think that's enough for this video.